maybe I'll just open the discussion here, and then we see how it moves on. Okay. So you're all involved in the production of catalogs of X-rays from the detection all the way to the publication of these catalogs, and they have a large and diverse content. And I wonder, what is the ideal content of a catalog, and if you have ideas on what is the best way of actually publishing it. So, yes.
So, oh, again, first. Oh, that's okay. That's unfair. So, as you probably understood based on my talk, I really see the catalog as the most advanced processing layers that we can see that can sit on top of the Chandra archive. So, as far as I'm concerned, a catalog should be the most time-lasting legacy of any mission. But at the same time, I think that it should be provided to users as soon as possible, given some limitation that in the Chandra world have to do with the proprietary time or privileged usage times of most observations. And that's something that should be discussed, even though it's not technical in nature. So my take on this argument is on this particular topic is that, if that was the question, is that we should provide access to tabulative properties, which are the quickest things users would look at the same time to the data products that are being used to calculate those. First of all, because it kind of increases openness and trustworthiness of the catalogs, right? Users in principle could reproduce the numbers that we published. But most importantly, that allows slightly changes to the processing methods that we have used that fit specific use cases. That's one of the problems of the general telescope like Chandra and XMM and Athena, right? They will cater to so many different use cases that it will be impossible to find one recipe that fits everyone's needs. So the only way to make all the science possible is by opening up everything, including data products, at the catalog level, of course.
Okay, yes, I agree with what you said. I conducted a small poll last Friday in our group meeting about this discussion and what our what my colleagues think about it. And so, well, we came up with the question or with the statement that the catalogs between different missions should be somehow homogenized, standardized. I mean, for example, the energy bands, that's an important point. I mean, not all missions, of course, overlap in their energy range, but if we can, we should somehow agree on certain energy bands. And the same is true for the calculation of ECFs. Of course, it's very, well, people disagree on the matter of fluxes. There are people who say, no, fluxes shouldn't be in a catalog because there is no X-ray flux. It depends too much on models. But of course, this can partly be overcome if you also agree on the calculation of ECFs, if you agree on certain standard models. I mean, there can be more than one flux in a catalog. There can be a flux for a thermal model and for a power law model, maybe different absorption values. Because I mean, we have a long history. We have 60 years of X-ray observations now, and you might want to use a tool like Aladdin or so and plot a light curve with a mouse click, be able to plot a light curve of a source during the last 60 years or so. And that is probably only possible if the data products are homogenized somewhat. And well, another point, well, in a similar direction is maybe light curves. Well, for spectra, we have a standard. We have the OGIP standard, and well, most people use XSpec or similar software for spectra. But light curves are, there is no real standard, and usually you don't have fluxes in light curves. You have rates which might be exposure corrected, but no fluxes. So that was the outcome of the little poll I conducted.
Yeah, and continuing on this to contribution, perhaps the summary, maybe creating a catalog is always also a matter of compromising, especially keeping the different groups of users in mind. Here we are more a group of specialists who are interested in the details, who are able to convert a count rate into a flux. But on the other hand, we also want to reach those who are less experienced with X-rays. We want to offer products that people working on optical sources can use to look for counterparts and to understand what is in the catalog, and to have recipes to read that. And I think this is also something we should think of for the accompany them with recipes. So yes, I know I also get enough emails like that. I know that not everybody likes to read a manual, but if there's a recipe how to apply an ECF, or how to convert between our different catalog fluxes, this would, even if it's not true for each individual galactic source, if we have some standard recipes, so that the person who goes into the Swift catalog and the person who goes into the eROSITA catalog, but mainly works on optical data, knows what to do, this definitely would be an added value.
Thank you. It's getting harder to say something original now because I agree with everything that's just been said. Maybe I'll start with that last point because I completely agree. And the thing is as well, you know, if you're an optical person, you know how to convert between a Johnson filter and a SDSS type filter, you know, or at least you ought to probably. But it's really difficult to know how you convert between two instruments. And even, you know, then you get into eye check and cross calibration uncertainties and we'll start whimpering. So from that point of view and thinking ECFs, I get your point about standardizing ECFs. I think what I would really push for, though, is whatever you do in the way of ECFs, make sure your catalog contains the count rates, first of all, because that way anybody can decide to change their ECF at any point in the future. And if you're studying, say, an X-ray binary, its ECF changes massively depending on what state it's in as well. So I think that I would keep count rates. I think where there's an issue to me, therefore, long term, is as everyone has already said, there is no one set of products that everybody wants. So it's great if you can provide the tools that say, hey, here's what we've done with the catalog. Go and we heard from the XGA stuff earlier on, for example, I've done this with Swift, that you can go and say, hey, I want something a bit customized, click, 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 click. I'd love to be able to preserve that kind of provision, you know, to infinity and beyond, but there isn't really infrastructure for that because that's processing power. That's not just a catalog. So there's some interesting questions about long-term data curation and availability, because you also asked, wasn't it, how should we make catalogs available? Do I get brownie points for saying through Vizier? Is that the right answer? But as you might have guessed from my question earlier on, I'm very much in favor of making tabulated data because there's tools that everyone uses, or probably uses TopCat, right? We know how to use pandas, or I'm supposed to say Astrofits tables, but I prefer pandas. You know, there are various tools that exist for analyzing tabulated data, and I've got nothing against custom tools for each instrument, but also just give people the damn CSV file so that we, or FITS file or whatever, so we can load it into our favorite play around editor and mess around with it. That would be my big take home.
Right, yeah, again, this is all true, so I'll try and think of something new to add. I guess my perspective is from a much smaller catalogue. So, you know, the XMM project and all of the Swift and Chandra and all of these have a lot of people working on them that can produce, you know, well, relatively compared to the New Star catalogue, right? Can produce a flux for different models and something. But I think for a smaller project, that's just it's not going to be possible. So we have to think about how to strike the right balance between providing a catalogue that's useful to as many people as possible, but also using our time in the best way to produce what would be useful to most people. And perhaps these sort of the interlinking with other catalogues is kind of something to prioritize. I don't have the answer for what should the priority be, but I guess, yeah, my comment was perhaps we need to discuss what's the best thing for smaller projects to focus on before other things. Thanks.
No, actually, I wanted to rebound on one of these points that was raised earlier on, actually, about publishing as soon as possible. So we've heard from a number of different catalogs. I'm not pointing fingers and I'm not trying to be nasty to anybody at all. That wasn't my aim. But I mean, we've heard like there's catalogs for New Star. It's publishing data up till 2019. I think the same is with the first eROSITA catalog is 2019 data. the Chandra one is until 2021. And it just kind of highlights the fact that it's actually very, very difficult to produce a catalogue. And I think that's the first thing that needs to be acknowledged, is that producing a catalogue is really, really hard work. But yeah, I think you're right, that the catalogue needs to be as up to date as possible. And I guess the best student in the room, then I'm going to point fingers, is Phil. Okay, because you've got a catalogue that's always up to date. I don't know if you want to give us a comment about like how easy that is to do. I know obviously Swift is slightly different because your data has not got a proprietary period, so that makes things a little bit easier. But I mean, it'd be the ideal thing, you know, the day that a new observation comes out, even if it has got a proprietary period, that it gets added into the catalogue automatically. I mean, yeah. So do you want to give us some insight into how difficult that is?
That's a good question. So I have a team of one, is my team for the Swift catalog, is me. I get some help from Kim Page with some of the manual analysis. The catalog I'm going to tell you about tomorrow took me 7 years to build, but I have other things to do. That's not 7 years, 100% of my time. The real issue, so we have a latency of 10 days, which I think could come down to 3. There's just a technicality of the data. The problem is what you can't do is put data that are not complete into your catalog. So if you get a partial data downlink and the data are going to change, what I find is the biggest issue for X-rays, and I guess, I mean, Chandra maybe doesn't have this as much because you get really good astrometry, right? XMM is better than Swift, but you've still got a PSF of the size of us. Is what you do as your catalog changes, you find you've got a source that's maybe got it's not a great source. To first order, all your sources are at your detection limit, right? So it's got a kind of crappy position. And then you get a bit more data and it moves, and then it moves back again. And then sometimes what you find is now you've got a lot of data. It's actually 2 sources really close to each other. And managing this is what gave me the most nightmares, and it's still what kills my processing time. Actually, if you look at the warnings I get scripts that run too long and they warn me, it's all because of handling sources. So actually it'd be really interesting to talk sometime offline to you guys from different catalogs about how we deal with this when you're updating your catalogs.
I'm going to just say that is, yeah, our biggest problem as well. We have this problem. Every new version of the catalogue is an absolute nightmare. I mean, in some respects, maybe the stacking helps, but I think we still have the same problem with the stacking. But yeah, it's a really difficult problem to overcome. But yeah, so you managed to get your thing into catalogue 10 days after you've got the observation approximately.
Yeah, I mean, it's about, okay. In an ideal world, it's about 20 minutes after I get the data, but in the real world, it depends on how fragmented the database is actually. It takes about between 40 minutes and 3 hours to get a source list into the catalog once it's hit the final state. And 99% of that is the source matching stuff. Yeah. But we only have one. It's listening to your talk in particular really makes me appreciate the benefit of only having one instrument. Yes and no. We have, okay, so screening. So the question for those online was, are we in Swift screening sources? Because XMM, I think you manually validate every single field, don't you? We don't have the staff power to do that with me and some of Kim's time. So what we do is I have a pretty reliable system of identifying things that need screening. So if fields, there's a certain set of characteristics and I say this needs manual validation, and those ones are then screened manually. And I guess there's probably between about 5 and 20 a day, depending on what mood Swift is in, that have to be looked at manually. Usually it's a pretty quick case of going, yeah, it's fine, click, go. Stray light sucks. I'll just throw that in. Yep. I sort of dealt with stray light, but the model isn't, yeah, that's a different story. The model's not quite perfect, so, yeah. And this universe is dynamic. If the universe would stop changing, life, can we all agree that if the universe would stop changing, our jobs would be easier? I mean, yeah, okay.
Oh, hi. So I'm about to say something that's going to have me excommunicated from the X-ray astronomy community, probably. But with this discussion on ECFs, we still use fluxes in big broad bands that sit very strangely with our actual effective area files. So we tend to include lots of flux in bits of our telescope's response where we have effectively no response and all that. Yeah. We could solve this problem of ECFs being dependent on model shape and all that kind of stuff if we were to take the backwards seeming step of adopting AB magnitudes instead of fluxes, like everybody else in the astronomy world, apart from far infrared astronomers. It doesn't need to be narrow band, but the point about an AB magnitude is basically a ratio of flux of an understood spectral source in a defined band. That's basically what it comes down to. So if you look at a different source, it's straight, you compute it from the count rate, nothing else to do with the model. And you define it that way.
Well,
And
there is a,
that's the advantage of it. And everybody hates them, and the extra astronomers are all looking at me with, you know, I'm going to be assassinated. I may not make it to tomorrow's sessions, but that advantage that it doesn't depend on the model.
well,
for
there
an
is
individual
the unit
source.
crab. That is basically what you mean if comparing to a well-known source. So
Well,
you can use millicrab or
yeah. But millicrab, still people would define millicrab in terms of flux rather than count rate, because most people aren't measuring the crab with their instrument and so forth. So it's.
Like that, I can pass it along. Okay.
So a couple of things, a couple of notes about what has been said, which I agree. So about 20% of the help desk tickets that we get at Chandra X-ray Center about the catalog, how can we reconcile these values, whatever they are, we will, as found in the XMM catalog? It's your fault if we work a lot. And I'm just saying that it's inherently complicated to give those answers because it's, and so I'm trying to remember the kind of points. Something else that I wanted to mention, I want to give an explanation of my last slide. When I said catalogs should be day one deliverables, it was kind of a self-deprecating humor because one of the criticisms that the community has done to the Chandra X-ray Center is not being able to keep up with the archive. So we make a great effort in trying to go from basically the end of 2016 to the end of 2021 in terms of coverage in the catalog, right? But in the meantime, the archive has accumulated other 3+ years of data. So the way that we've seen forward to try and minimize this gap is not by providing an online or inline or instant Chandra source catalog 2.0, 2.*. That would be impossible. It takes years to develop that. But something else that could cater to specific use cases, for example, transients, right? And I'm not saying that it's city or but it's definitely less time consuming than coming up with a new full review of the Chandra source catalog, which is really a lot of work. Also, and I will shut myself, yeah, I understand it's very nice to talk about technicalities that are only of real concern for the X-ray astronomy, but remember that when we are trying to ask money to have something as costly as the Chandra source catalog, I could give you the number of FTEs per year that we've invested on that. You want to make sure that you're giving data in a format that most astronomers out there, who are not X-ray astronomers, would understand and be able of using, at least at the simplest level. That's a concern. Fluxes are important because other astronomers understand what we're talking about, even though they come with a lot of dependencies in the high energy in the universe. And convincing people to give you money to develop this catalog is difficult.
So the other comment I'd make, I'm looking at you here, Matt, as well on this magnitude. Maybe I've misunderstood because I'm not an optical person. AB magnitudes is one of those black magic words that people from some other world speak in. But you have a big issue comparing is this wavelength and sensitivity thing, which is where I don't see how this. So maybe I'll explain my question to you. The first time I tried to build a transient detector in XRT for Swift, it was a disaster. And the reason was that I would find a source and I'd say, is it in the ROSAT All-Sky survey? No. What's the upper limit from the ROSAT All-Sky survey? Wow, we're well above that. This is like 1,000 times brighter than ROSAT, and ROSAT never saw it. Then you take a spectrum and you realize that's because it's heavily absorbed and ROSAT shouldn't have seen it because the absorption wiped it out in the ROSAT energy band. So your filters must have to be relatively narrow to make this. So I'm just wondering, with your view, how you get around that, which is the same cross-calibration problem we're all talking about, saying, how does my XMM source compare to my Chandra source? Oh, by the way, they were observed on different times and these sources evolve and all that kind of crap. But how do you get around it from magnitude?
Well, if you're an optical astronomer, or something like that, you'd observe it twice in the same band. You wouldn't say, oh, well, it was bright in V, so now it should be bright in R. You'd have to worry about the color, the difference between the bands if you're going to use two different bands. So, and even if they're broad bands that cover the same range, but they've got different shapes, of course you'll get different magnitudes.
Okay,
Like, so that, I mean, it's just so the optical astronomers just have a completely different way of looking at this kind of problem, I think, is that.
So your point is that you
short
would still split say that, you know, we all cover, apart from you, sorry, most of us cover 0.3 to 10 kV. Some special instruments do much more excitingly hard energies. But you know, but even then the same thing, you know, if you said let's make 3 to 7 kV a band of interest, you would have reasonable sensitivity in there. We'd have essentially NAF all in there in Swift and so on. I'm struggling to see how that works, if I'm honest with you. Maybe we should talk offline. I just feel you're going to end up with a series of filters, and each instrument, because of where its effective area curve is, peaks in a different filter. So your ability to then compare one instrument to another becomes trying to compare a V filter with an R filter. And so you've still got the same
It
problem.
doesn't solve your problem that the different instruments are covering different energy ranges. It doesn't solve that, but it does solve this technical issue of ECFs being dependent on a bunch of assumptions being carried through to what your final fluxes are that get published. So actually the flux is wrong because the source has a different spectrum to the one I assumed. That problem's gone because the way a magnitude is defined is just being the
Right,
do with
so-
the ratio of fluxes from some standard.
So your problem becomes
source.
that your assumed color is wrong because you've only measured it in one band and you've guessed what it is in the R band to compare it with the other
Well,
instrument, and that might be
And
wrong.
that's something
Okay.
like that, yeah.
Okay.
Well, a typical optical filter would maybe correspond to an X-ray energy between 1 and 1.2 kV or so. That is, I think, a major difference between X-rays and optical. So
True, that's right. I mean, the Euclid this filter's going to go factor of 2. I mean, and there's a white light filter on Swift which goes from 1700 to 8000 angstroms. So it's not uniquely true that in the optical and ultraviolet and other wave bands, the filters and band passes are all very narrow. It's certainly true that X-ray astronomy tends to have very broad band passes for its instruments, but I don't think this is the reason we use fluxes and they use magnitudes is essentially historical. It's to do with the, you know, X-ray astronomy were physicists who flew Geiger counters and thought in terms of fluxes of things that were like particles, whereas, you know, optical astronomers started with their eyes and went on to photographic plates, and this is just completely different history of development as to why they came up with these different schemes of calibrating their observations, I think.
At the end, if you want to mix, if you want to mix optical X-ray information, for example, an LCD fitting, you have to take all this into account, the shape of the filters and everything. So everything gives you a consistent thing, and it's actually quite important. Mara can tell you that if you mess up with your filters in the optical, then you get completely wrong results. So it's a way of hiding things in a sense.
Can I ask, Rafael, you had this plot with these blobs that were all connected. And I had to think of the time years ago when we were talking about keywords. ESAC had its own set of keywords. CDS had its own set of keywords to describe catalogs. And at that time we had at the ADS and at Godot also a different set of keywords. And nobody could agree. And I was thinking, you're developing a system where you have these relationships between different entities. Do you think that is a unique thing that everybody will adopt? Or is that something that we should agree on, that if other catalog entities are being made, that they should be made in the same way so that they can be interactive to each other?
Well, that would be a very nice angle. I don't see different, for the time being, different mission adopting exactly the same methodologies. But I didn't tell what kind of methods we're using, because methods are not really the essence of what I wanted to try, the pitch I was trying to make, which is simply that when you have a very long-lived observation, and we are so lucky to have at least 3, I would say, including Swift, and a new star is going to be the next one, cross your fingers. we could use all the information that comes from annotations, which are not standardized by any means. So we use standardized keywords for mostly how we encode data into FITS files, and we abide by the HESOC specification, but that's not exactly how we would express this kind of relationships. So hopefully this will become the norm as we go towards an era where basically data-driven decision will be everywhere and will come in a way for free, you know, just like other kind of information about the data were relatively not very expensive 20 years ago, like describing observations by specified metadata in the keywords of the FITS files, which is still useful for some things, not really for the kind of discovery process that I was describing.
I feel like I have to contribute there. As a member of the CDS, I work in the VCR team and Simbad, and we deal a lot with annotations of data. And while externally, what you see are names of columns that are the names of the columns that the authors have given to a publication, internally, it would be impossible to work like that. So we actually do standardize those columns. And we have specific keywords that are associated to the physical quantities that we're describing. And it could be a physical or it could be a physical, like a ratio, because you don't have units. So it depends on what you're computing the ratio of. But we have ways of describing that. I mean, I can give you more details on that. And this can be transmitted into FITS files. It can be transmitted into VO tables. It has been unified at the interoperability level at the IVOA, and there is a keyword that doesn't fit to your specific needs, it can be invented. So, but the idea is that we can in the future use tools that allow to ask not for the name of a column that can vary from catalog to catalog, but for the physical quantity that it actually transmits. Yeah, I just thought that. Maybe I don't know if we have we have a few more minutes. Within those few more minutes, maybe I'll ask another question to you guys. So quality and reliability of catalogs. So do you have any thoughts on how to optimize that and how to give hints for future missions? Yes.
Okay, so I think this goes back to almost what was said earlier on. People are just going to use things at face value and not read the documentation. And that's one of the big problems I think we do come up with. And I get this problem with the XMM catalog is that people just use data by taking it at face value. They don't look at any of the flags that we've spent a huge amount of time, especially as you mentioned, that we do actually screen every single detection in the catalog, which is a lot of work. And people don't even bother to look to see that actually this is a really bad quality detection, and they use it like, yeah, we found out, we've proved that this AGN has got X-ray flux, but actually probably doesn't, because yeah, it was a really poor detection. So I'm not quite sure, to be honest. I think, yeah, it's something I've thought about an awful lot, but I'm not quite sure the best way to be sure of the reliability, so that any user that picks up your catalog is actually sure to understand what the significance of that source is. And it's something that worries me. I can see Mara's got something to say, and that's cool.
And what we could do is having catalog splits in reliability. As we did for eROSITA, we have the catalog where we are certain 99% that there are no spurious detection in. And this is what we trust. There are still flags because there are still sources that are nearby, the Vela or pulsars and such that are spurious, but we flag them. But the rest is on something else as a supplementary catalog. And then people that are really want to dig into something that is only 10% real data, 90% noise, they can go to look. But we try to help them in giving something that if you really want to trust the work, then look this catalog, not everything together, and this can help.
Yeah, so it's actually something we looked into immediately after the meeting we held here in 2018, because I think this point was raised. looking at Norba here, because he was not happy about this idea of having two different catalogs. So we didn't actually go that way. But you do want to provide a maximum number of sources. Many of the sources, even only at 3 sigma, are actually real sources. But yeah, then there are a number of things in there. And like I say, we do make a big effort to try and provide the most reliable set of detections by the fact that we've actually screened them. But yeah, how you get people to look at that information is complicated.
Yeah, I totally agree. Is I think impossible. And one of the choices we made in the New Star catalog was to provide all this information about the counterparts, so we could look at do all this optical spectral follow-up, which I hope will be really useful. But I think that does introduce another layer of, you know, these are the counterparts we think are, and we've looked at the probabilities and all of that, but some of them won't be, because that's how probabilities work. And so, you know, we've tried to write really carefully into the paper that, you know, these are caveats and you should, you know, think about your science case and whether these, you know, look at them in detail. Like, for example, when I've been looking at the follow-ups, sometimes I've redone the background and found that a source that's in the catalog shouldn't be, and, you know, there's probably other instances, but I think, yeah, it's useful to add the extra data, but it does add an extra layer of potential for people to take the catalog as fact when what they should take it at is probability.
Thanks. I guess I'll add a couple of things. I mean, first of all, I totally agree with you. Hold that thought. The first thing I would say personally, from my point of view of what we can do to ensure our catalogs are as reliable as possible, I mentioned this in a question earlier, I'm all about the simulations. You know, it turns out that the only way of knowing, you know, that in order to know that your processes are recovering the correct information, you need to know the correct information. And the only way to do that is to invent it. So the more reliably you can simulate data and therefore be able to give people quantified statements to calibrate your flags and so on, I think that's hugely important. It's a pain in the backside. It takes flipping ages, but it's really, really important. That's the first thing I'd say. I think trying to keep your flags simple, even if you've got, it's difficult to do because you're suddenly like, yeah, but I need to do that and I need to do that and I need to do that. We went with a kind of good, bad and ugly kind. It was good, reasonable and poor, because I'm not allowed to call it good, bad and ugly. But, you know, a kind of trying to keep the flagging simple for people. And the other thing, I don't know if this helps with this compromise between multiple catalogs. So within the Swift catalogs, I have the full catalog, the clean catalog and the ultra clean catalog. And by default, what you get is the clean one. But these are not separate catalogs. What these are is a set of predetermined filter criteria, which are published and they're there. So at the back end, if you go and you search for the clean catalog, you don't get a different catalog. What you get is and then a whole series of extra SQL queries tagged on. And that allows you to have one thing. But by default, basically, if someone doesn't think, then they get something that they, okay, you never, Douglas Adams said, never underestimate the ingenuity of fools. So it's not foolproof, but at least you can make it as foolproof as you can. I'm just going to tell you a little story. I was at a conference once and someone was presenting this result of Swift data, right? And they had, I don't know, I'm hoping, I don't know if that person's here. I hope not, because I've forgotten who it was. But basically it was of an AGM. And at the start of almost every observation, it had this massive spike, right? And the data would go wee up like 2 orders of magnitude or whatever, and then fade back down, not quite 2 orders of magnitude, factor of 10, and then fade back down, and then it'd be fine. And then they do it at the start of another observation, and it always only ever occurred at the start of an observation, and surely that should ring some alarm bells. For those who care, it's to do with the fact that Swift was still moving slightly, and the source could go over a dead zone on the detector, and then we hadn't at that point, because no one had complained to me about it, done a time-resolved solution. But if people... Surely every scientist knows. I mean, come on, every undergraduate should know. If you get an answer to an exam and it looks wrong, it probably is, right? and if people are doing research and are not able to say, hang on, these results look a bit funky, I ought to think about them, then I kind of despair a little bit. And you can't proof against everything. Anyway, so that's my rant over.
Yeah. I like the idea of using standard selection phrases over the idea of publishing different catalogs, which may give both those who host the databases a headache and the users. Like in your example, if you give the catalogs different names, even with the 2 catalogs, slim and full, the user will first ask, what is this? And the second thing, it is a really, don't underestimate the work to set up good filtering criteria, especially if it comes to screening. So I am the person who does, who screens a catalog alone once per year. And I think being the same person is the, well, the best point to become or to reduce the subjective part. If different persons screen, they will have different results. And doing it alone, I can tell you, if you give me the field in the morning and in the evening, the results will be different. So there's always a component in there. There's something maybe slightly above or slightly below the threshold for numerical reasons, for personal reasons. So making the selection criteria transparent, but then sticking to one catalog would make sense to me, and to provide the users with recommended selection expressions for the clean catalog, but leave them the freedom to change that.
No, it's just, I totally agree about this idea of, giving flags and then a selection and make things easier to at least the less experiment users. And you have this example, for example, in SDSS. I mean, in SDSS, you have a flag that is clean, clean photometry. If you actually look at what that flag means, it's a pile of conditions and flags of this and that. And I mean, this is what you were saying before. It's about granularity, right? It's okay. You have in the bottom all this information that can be accessible, but you can put layers on the catalog and make things easier through these kind of tools. And I think also this is coming from, the idea of a catalog is a single table, and you get that, and that's your catalog. But nowadays, the catalog is actually like a combination of tables, and we are seeing this, for example, in the XMM to Athena. When you try to put things, and you cannot put everything in a single table. You have to start thinking on how to put this in a proper database, and then you can give examples to the user on how to do queries on this and mix. But yeah, I think sometimes we need to switch from this idea of the catalog is a table. The catalog is actually something much more complicated and needs to be dealt with.
Norbert Schuttle speaking. I would say keep only the very good catalog and throw all other sources away. 40 years ago, we were using paper. Nobody would have wasted any pencil to keep these rubbish sources. The particle physics use 5 sigma for every detection. And how many rubbish paper we have with 3 sigma detection around. It is bad culture. Now we spend the money to screen all the things, and then we keep the weak detections which you don't believe. Throw it out. But many people use a catalog. In the beginning, people wrote XMM Newton view off. Now people have 10, 20 different papers, different instruments. They don't spend the time to check the things. It's a completely illusoric. And if you make a good catalog, you have to make a decision for them. And don't mislead them. And if you find a weak source, if you go to an AGN, if you detect an X-ray flux with 3 sigma, with 5 sigma, with 2 sigma, nobody cares. But if something has consequence, I saw this one, when the whole auditorium of 300 people laughs about XMM rubbish, and people sit in front and have to defend it or to try it or even don't try it, then it looks different. Astrophysics, we don't care about most publication, but there are important things, and then it cares. And then 3 sigma is not sufficient to really make something sure. Therefore, don't worry to throw the rubbish away and make a good cut better than 99%.
So the problem partly is what you can as rubbish. I've got a 25 sigma source. It's as real as real. It's as real as you or me, but it's right in the middle of a big band of stray lights. So it's flagged because it's real, but the count rate measurement is going to be distorted and the spectral shape is distorted. Do I throw that away? The thing is I understand where you're coming from because you're the PI of a mission and you have a concern that it looks bad for the mission if people do bad science with your mission. I think it just looks bad for them for not being able to do science. You know, and I've been there and done mistakes probably. I'm not going to own up to that too much in case, you know, but the thing is, well, maybe, but you know, at the end of the day, what you're doing, if you're creating that cut and you're saying we're putting this threshold and we're going to throw away a load of stuff that we believe to be real, but there's just something that might not be right about it or that could be just low, you're deciding what science case people are going to do with your legacy data set in the future. You're deciding that when someone discovers this new type of phenomenon and they want to go back and they're rare and they find out, you know, there's only 3 expected in the whole of XMM's life and they were going to be faint, oh, it's impossible for us to tell because the catalog trashed all of those data. Whereas if you keep them, okay, they're in the catalog, you are relying on the scientist to be able to use their brain, but you're allowing the intelligent scientist to do that and to filter. So I know you're concerned, but I personally think keeping the crap and saying this is probably crap is better than throwing it away and making it impossible for people to use it. I just think that setting the bar so high, I can't buy that. So, go on.
Perhaps just trying a summary catalog. People like discovery of unexpected things.
Yes. So I'm very sorry. We're a little bit past the time. So I think, I mean, go ahead.
Okay, I just
and
wanted to
then
say,
we're gonna keep it there.
in
okay?
terms of looking at the catalogs in combination, like particularly with the New Star and their AGN, a lot of the time fitting them with New Star and XMM is useful, but sometimes the XMM detection is not super strong. But if it's detected in New Star, you can be convinced about this 3 sigma detection. So it is useful to have those in the catalog because when you put them with other things, they become more convincing than that stats would say.
Okay, that's perfect ending. So, again.